Hi everyone, welcome to Project 21, this is DG57.com saluting you. In this video we are going to talk about what initial capital expenditure means when a mining operator announced the construction of a new copper mine. The data provide a benchmark for 3 selected projects already constructed. But first a brief description of how a copper mine works. Images show a copper mine scheduled to have equipment consisting of hydraulic shovels, haul trucks, and a loader capable of loading the haul trucks, which has rotary drills plus a fleet of support equipment. The haul trucks will dump thousands tons per day of ore directly into the primary crusher. The ore is crushed to about 6 inches in diameter and is conveyed by an overland conveyor to the coarse or stockpile located behind the concentrator building where ore will be processed. The following is a brief description of how things work out in the concentrator building. Everything inside the concentrator building is controlled by a state-of-the-art electronic system that allows operators to monitor the whole milling process. From the central control room, operators can see everything that's going on in the process from crushing the ore to the final product. From the coarse or stockpile, the ore is conveyed into the concentrator building, and it is the 34-foot diameter segment that is powered by 2 8,500 horsepower motors. In the segment, water is added with the ore and tumbled with 5-inch diameter steel balls to grind the rock to less than 2 inches in size. This product flows to a 12 by 28-foot vibrating screen that allows the ore that is less than a half-inch in size to drop through the screen and be pumped to the 2 ball mills for further grinding, or that is greater than half an inch travels across the screen and is conveyed to a pebble crusher where it is crushed to approximately half an inch in size and returned to the SAG mill for further processing. The 224 by 40-foot ball mills powered by 4,500 horsepower motors use 3.5-inch steel balls to grind the ore finer. The ball mill product is then pumped to cyclones which separate the coarse material from the fine ore, with the coarse material reporting back to the ball mill. The water and fine ore, which is ground to about the size of salt mixture, flows to the rougher flotation circuit. The separation of the barren rock from the copper minerals is performed in the rougher flotation cells. Flotation cells have impellers that mix the ore and water mixture. Bubbles are created by adding air and small amounts of alcohol to the cells, and the copper minerals are coated with a collector that allows the copper minerals to stick to the bubbles in the flotation circuit and float to the surface. The mineral concentrate from the rougher flotation circuit contain about 5% copper. This concentrate is further treated in the regrind mill and cleaner flotation columns to produce a cleaner copper concentrate containing approximately 25% copper. The cleaner flotation concentrate, which contains the copper mineral that has been ground to the consistency of talcum, flows to the thick ore where the solids settle to provide a mixture containing 50% solids. This thickened concentrate is then pumped to the filter press panels where the moisture content is reduced to approximately 9% moisture. Now, returning to the topic of initial capital expenditure. The goal of this video is to talk about what initial capital expenditure means when a mining operator announced the construction of a new copper project. This data provide a benchmark for 3 selected projects already constructed. Capital expenditure is known as CAPEX in the world of engineering projects. In terms of citizens, it is the project construction budget. We present 3 examples of construction budgets for 3 copper projects to know where these capital expenses go, or to know how these numbers should be read. The figure on the front presents a benchmark that illustrates the breakdown of capital expenditure into its main components, to provide a better idea of where the capital is being spent. It begins by showing the highest category components within the budget, which are the construction disciplines: earthwork, concrete, steel, mechanical, electrical, instrumentation, piping. Then it goes on to the items that make up the indirect costs. Then it goes on to items called owner costs, expenses generated by the project owner, and contingency, unforeseen expenses. By showing direct costs, indirect costs, and contingency as a percentage of the total, it is possible to get an idea of how each of the project components is weighted. The figure shows 2 weighting types. 1. The weighting of the construction disciplines with respect to the discipline that generates the major expenses, which is the mechanical discipline, which refers to the major mining processing equipment, and 2. The weighting of the mechanical discipline, the direct costs, the indirect costs and the contingency with respect to the total project. Now, what is the reading of these two weightings telling us? First, the mechanical discipline reaches an average of 25% of the expenses of the entire project and, in the cases of Peru and Panama, this is an initial capital expenditure that as an amount does not reach their local economies because the equipment manufacturers have their facilities in North America or Europe and now also China. Second, the initial capital expenditure called contingency that reaches an average range between 10 to 15% of the total of the project is an amount that is set aside for cases of unforeseen situations, which may or may not occur, that is, it is not a confirmed expense. Third, direct costs can reach an average range between 55% to 65%, which includes 25% of the mechanical discipline. The weighted percentage of the other 7 disciplines is divided into labor costs, materials and construction equipment. In the case of materials and construction equipment, these have a large percentage of foreign origin, that is, only the labor component has a major local percentage. Fourth, indirect costs, as numbers in the figure show, can reach an average of more than 20% of the total, and a large part of their components are of foreign origin as well, which can reach a percentage of 25% of direct costs. Now, for example, what else are the numbers shown in the figure telling us? In the case of the Panama project, there is a huge initial expense in the site preparation discipline, which practically triples the amount of the major discipline called mechanical, which distorts all the weighted percentages of this project. This is due to that the mine is located in a jungle area with high rainfall, no access roads, and poor geotechnical conditions of the terrain for the construction of such roads. What else are these numbers telling us? A common comparison for copper development projects is the capital intensity of the project. The final 2 lines of the figure show ratios in relation to the annual copper production, one with respect to direct cost expenditures, the other with respect to total project expenditures. As can be seen, in the cases of Peru and the US, these ratios fall in similar range. If you are new to this topic, now you got a pretty much idea how the initial capital expenditure estimated for a copper concentrator plant must be read, in order to get the right conclusions. These initial capex expenditure description refers to a budget estimates for an EPC lump sum copper concentrator plants. This data provide a benchmark for 3 selected projects already constructed which are located in Panama, Peru, and USA. So, I hope you all find useful this presentation. If you like this content, don't forget to subscribe to the channel, like, and leave a comment. Thank you for watching and I will see you in the next one.